Hey YouTubers, here I have two boxes. One holds the 783 Hudson, the other one is a T1484 Reading steam locomotive. Let's work on the Hudson today. I got this locomotive at a flea market for a very reasonable price, and for the price that was offered, I'm not going to pass it up. So the owner told me that it does run very, very slow, and it does have a motor issue. So I'm like, all right, I'll take it and see what I could do for it. So I got home, I put it on my tracks, and the first thing I noticed that this locomotive is very heavy. So it's going to shake the table, and I think that's pretty awesome. So I went to turn on the power, and I almost had to push the throttle all the way forward to make this run at the speed that you see right now. Now, I don't think that's top speed, but I heard that the Hudson does run slow, but I don't think that's slow. So I went online to look for any line diagrams to take this apart, and I couldn't find anything. So I'm going to take this apart blindly and record everything so that in case you want to take apart your Hudson, that you won't make the same mistakes that I did. But hey, it's a learning experience, I'm going to make mistakes. So my intentions are we're going to clean it up, we're going to upgrade to a new smoke resistor, we're going to put an LED light into it, any kind of repairs necessary, and see what I can find with this. So let's take it apart. This is the only time the 783 will make it through an 027 switch perfectly. Okay, so the locomotive is fully disassembled with the exception of the wheels, and this is the cast iron frame that is left behind. And this is a nice, heavy, chunky piece of metal right here. We can see on the frame here that there's the magnets for the magnet traction, so we have magnets 1, 2. There's one over here, and the cover for the worm gear did have 3 magnets on here too, so 6 magnets all together here. Just inspecting the frame, make sure that there's no cracks or anything on here, anything that would cause any issues, especially if you look to see on any sharp corners if there's any Insulation of the wires rubbing on here just so that there's no electrical issues associated with this, and I don't think that there is at all whatsoever. But my main concern right now is this grease that Lionel used, that since that it has broken down into this oily substance, and you can see here that there is like an oil patch right over here. There's some back over here. And Lionel also used the grease here on the push rods, on the wheels, and on the bottom the oil has seeped down to where the pickup rollers are mounted onto the bottom of the frame. And that's not good because this oil is not electrically conductive, nor does it have any kind of electrical properties to it, so that will rob your locomotive of performance as well too. So we're going to give this all a cleaning and stuff. We're going to put new grease in to make this run a lot better again. Also here, the push rods that are attached to the E-unit housing. There's a lot of grease on here too, all along the sides, and this is still kind of sticky as well too. So we're going to clean these up, and I think that this is where the performance was also giving me a problem too, because it's very sticky right over here too. So we're going to have to clean all this up too. Also, when I gave this a test run earlier, there was the tender does have mighty steam of sounds, if you will. They're Lionel's rail sounds, and I believe that this plate down here controls that. My problem was that I had an extended chuff sound with the tender, and I think that this may be stuck in some way. So I'm going to give this a cleaning as best I can so that the locomotive, the chuff sounds will operate properly when the locomotive runs. And with the smoke unit here we have the resistor that is for the smoke unit. I'm going to replace this with an 18 ohm 3-watt ceramic resistor so we could get a lot more smoke coming out of the smokestack. And obviously here we have be careful I don't touch all of this here. This is just a mess. This is the worm drive for the 783. A lot of the grease is sort of tacky on here and sort of has broken down. I can see there's like a lot of oil associated with this, and we can see the 3 magnets on here. Yeah, so everything's going to get a cleaning just for the performance of this, so it'll run a lot better. So I look forward to getting this running again just like brand new. So let's get started. While taking apart this locomotive, I still went online to see if I could find a parts line diagram, even a parts list, just to see how this locomotive was assembled, but I couldn't find anything. However, my research did take me to eBay to where I did find this book. It's the Greenbergs Lionel Modern Era Parts and List Diagram for trains, I think from 1977 up to 1992. It's a 600 plus page book of, well, what it says. It's parts line diagrams. I mean, anything that you're going to need here for fixing your accessories, operating accessories, rolling stock, steam locomotives, diesel locomotives. I mean, everything is going to be inside this book. This book, coupled with my post-war Greenbergs book, I have a lot of knowledge now and parts, part numbers to go by to fix up trains, you know, if I have to. So we're going to put that for a side right now. So what did I learn with this Hudson as I was working on it? Well, I found out that the metal plate underneath the E-unit, it was just the metal plate. It wasn't like the MPC locomotives where the drawbar pushes up on the piston, then pushes up on a contact to send the voltage to the tender for the static chuffing sounds. Even though the tender is tethered up to the boiler for all these operations, I think everything was integrated in there in the tender for voltage controlled steam sounds and such. So even though I haven't confirmed that yet, I have not yet touched the tender. Okay, so the motor unit, to fix that up, I went to replace the bushing. Now the new bushing I got seemed a little different, but not that much different. When I went to reassemble it, I did find out that the armature was frozen inside of the motor housing. And I thought, okay, well, what did I do wrong over here? So I took it apart 2 or 3 times just to find out, you know, what was wrong. Did I get something stuck in there, a piece of debris, or I don't know what I did. What I did find is that the new bushing was taller than the old bushing. And Lionel did use 3 thrust washers at the end of the armature to compensate for the gap up against the brush plate. So I took out 2 of the thrust washers, leaving 1 in its place, and everything worked fine. So a little mechanical, you know, hiccup there, and everything was working fine. Now you see that I did make a DC circuit for my headlamp. Now, why did I choose that other than putting a regular LED in place with a simple series resistor to the AC voltage source? Well, both of them have their pros and cons. The pros of the just the LED with a series resistor to the AC source, you know, fewer parts, less soldering, just 2 wires to hook it up, and then it's done. The only drawback to that is when you change your voltage, the LED can dim, and you know, it's not always going to be constantly on. With having a DC circuit, what I built, you could put any voltage source you want into it up to the specifications of the full wave bridge rectifier and the regulator, and the regulator will always push out 5 volts DC. Now this will always keep the LED on, and as shown here with the locomotive at a slow crawl, you can see that the headlamp is very bright, high luminosity, and even though the cars do show that they are very bright, they are actually very dim when you see this train run. Also, while the train was in standstill mode, the headlamp is very bright, and as we pan around to the passenger cars are not even on at all, or they are just very, very dim. So you see what the advantage of that circuit is, but it is a lot of soldering, well, not a lot of soldering, but there is soldering involved. There's more components. You have to know some electronics involved with this, but you know, each of them has their benefits and drawbacks. I did try to find a capacitor big enough to put in with this LED so that when I switch in from forward, neutral, and reverse, that the LED will always be on. But there are boiler restrictions inside of here, so I couldn't find anything just yet. But if I do find a good sized capacitor for this, I will pin it into my comments section below. So this Hudson was a great learning experience to take it apart and clean it and everything. And as you can see behind me here, I do have another locomotive, and that is the T1 Reading locomotive that I will take apart, clean for my next video. But that's also the prelude to the box I have over here, because that is also another T1 locomotive that I have not opened up in 30 years since I got it back in 1992. And what it is, well, subscribe, turn on those notifications, like the video, leave a comment in the comment section below. And thank you all for taking the time to watch the video. I hope it was informative for all. So let's go run some trains with the 783, and I'll see you all next time.